My name is Nathan Swan,
And then I'm Ish Ramesh.
and we are both AI engineers at United Airlines. We currently work on the AI platform team at United, and so we build AI tools and workflows internally for our platform team, and we also help enable teams across the enterprise to build, various AI solutions. We've been using LangChain for a while now, and I think as a framework, pretty exclusively. I think we're using LangChain, of course, more than any other framework right now. Today, we want to talk about one of LangChain's most recent frameworks, which is deep agents, and how we're leveraging deep agents to build a spec-driven development AI agent. So today, we're going to cover first some of the problems we're seeing with AI code generation. We're going to talk about spec-driven development and what that is. And then we're going to go into deep agents and some of the key features and why deep agents can help us in building a spec-driven development agent. And then we're going to go into our implementation, which is what we call the super agent, and how that is being used at United. And finally, we're going to wrap it up with some lessons we've learned throughout this process. So, as I'm sure probably most of us in this room know, software development is changing a lot right now. With the onset of generative AI, the models are getting better and better, and more code is being generated by AI. I'm sure most of you, if not all, in this room are using coding agents in some capacity, which is crazy because I remember just a year ago, this was still catching on to be using Claude Code or Cursor, any number of other coding agents. But now I don't know many developers who aren't using it in some way, right? However, one thing we've seen is that although we're generating code faster, that doesn't necessarily translate into more production level software. And so the code generated is increasing a lot, but the increase of, this production grade software isn't growing at the same rate. There's actually been a good amount of research into this, and they've coined it the AI coding productivity paradox. Basically, what I just mentioned. Google's Dora team also found that AI is amplifying a lot of the strengths of engineering organizations if they have good processes, but it's also amplifying the weaknesses that are in those engineering organizations. And so if there's more code being generated, but the processes aren't solid, this can actually exacerbate existing problems. And why is this? Well, the hard part about engineering was never just writing code, right? And we've seen that internally as well. Even though we're generating code faster, we're still seeing the same problems as before in engineering. Models can generate lots of code, but they still need to understand what we are building, who we are building it for, which systems it needs to integrate with, and what standards it needs to follow. Let's take an example. Let's say I ask my coding agent, I want to build a customer support chatbot. Now, immediately, there's a lot of questions here, right? Who are the users? Which channels? What data sources do we need to leverage? What are our company standards? What, authentication model and all sorts of other very technical questions. What fallback behavior and when do we escalate to a human, right? When do we need a human in the loop? So what is the coding agent going to do here? And models are getting better and better, so they're doing this less. But more likely than not, what the agent's going to do is it's going to start making assumptions. It's going to make assumptions about the architecture and what it should use. It's going to make assumptions about the data schemas. It might create mock data if we haven't specified a data source, right? It's going to optimize for speed and accomplishing the task that we've given it. And so that's why it's really important the way that we use these tools to develop code. The actual coding part is relatively easy, right? But the problem is understanding what our problem really is. I'm sure a lot of you in your own organizations have seen this when you're starting a project and you don't fully understand the requirements at first. And then a week later, the requirements change, and we need to change the architecture, and the integrations change. We need to rewrite code, right? The problem wasn't the implementation, it was the understanding of what needed to be built and how it needed to be built. So we thought amongst ourselves internally, if coding is becoming easier and cheaper, although some of the newer models might be actually challenging that. Fable is very expensive. But if coding is getting faster, how do we improve the specifications that we're giving to our coding agent? And so that led us to spec-driven development. And for those of you who haven't heard of spec-driven development, it's essentially this. Specifications become the primary artifact for these coding agents to use, and code is the output. And so a typical flow when you're using a coding agent might be a prompt and then code generation, right? But with spec-driven development, it's a much more refined and iterative process where we have a prompt, we have our idea, and then we generate requirements from that. And then from those requirements, we get into technical planning and architecture planning. And from that architecture and technical planning, we actually generate an implementation plan. We generate the code, and then of course those last steps of testing and reviewing. These are all parts of the software development lifecycle, right? Requirements, design, architecture, documentation, governance, and coordination. These are all very important pieces. And if you look at an enterprise, again, if you look at your own app development teams at the companies you work at, there are a lot of specialized individuals and teams that work on various parts of the software development lifecycle and part of the spec-driven development lifecycle. We have, on the product side, we have a product manager who's focused on the vision for the product and the high-level business objectives. And then we have business analysts who are focused on creating the business requirements. On the engineering side, we have UX researchers and designers who put a lot of time and effort into figuring out what the user needs, how something should be designed. And then we have the front-end developers who are actually integrating those designs into the code. Of course, on the back-end side, we have back-end engineers, and we have architects making architectural decisions and then documenting those decisions. On the ops side, we have a DevOps engineer, and project managers, of course, are overseeing all this work and coordinating it. And so as you can see, the software development lifecycle has so many different pieces and so many people involved in it. And so we thought, well, generating code might be easier. How can AI assist in all of these different pieces and all these different stages? And we really believe that it can assist in many ways. And we believe that by doing this, we're also able to catch mistakes earlier in the life cycle instead of waiting until they're embedded in our code. So as we thought about this, we thought, what kind of agent can execute, this kind of spec-driven development workflow that we're trying to build? See, we've been using LangChain frameworks for quite a while, and of course, the first framework that LangChain released was LangChain itself, right? And we were leveraging this for a lot of the first use cases, for prompt chains, a lot of summarization tasks, more simple, mostly deterministic flows that incorporated LLM calls in key places. Linear and not necessarily dynamic. And when it came to building more complex, dynamic tool using agents, definitely building these chains becomes a little more difficult to manage and to optimize. Then, of course, LangGraph came out, and a major innovation with LangGraph, of course, was the stateful execution and the ability for nodes to be able to read from the state and to update state, and the ability for the graph to branch and loop and pause for human review and then resume at a later point. And we built a lot of really good systems using LangGraph. It made iterative workflows much easier. Another key innovation in the agentic space was React agents. And of course, LangGraph made that really easy with the create React agent. React agents, for those who don't know, it's reason and act. And so this is an agent that reasons over which tool call to make. It makes a tool call and observes the output from that tool call. And then it reasons over that output and decides what action to take next, whether, make another tool call or what it may be. And so it's this reason, tool, observe, repeat, iterative workflow that allowed for more dynamic execution, flexible workflows, because now the LLM is controlling more of the workflow and what's happening. For our problem and for our desire to create a spec-driven development agent, we weren't just answering questions. This wasn't just a chatbot, but we wanted to be able to complete projects, which required a lot of tool calls, multiple documents and phases, long-running context, and very specialized tasks. And we realized that reasoning wasn't the challenge anymore. We had the React agent pattern, we were using that. But the real things we needed to think about were context management, agent coordination, artifact persistence, and context limits. And that's really where deep agents come in for us. So deep agents is a framework, again, by LangChain. I'm sure a lot of you have used it or are aware of it, but it's actually inspired by some of the most effective AI agents out there today. Think of like Claude Code and Manus. LangChain learned from these really effective agents, and I know it's also in LangChain documentation talking about this, but there's a few key patterns that make these agents really effective, especially for long-running tasks. And a few of these patterns, one is planning and delegation. So if we want to build, say I tell my agent I want to build an operations assistant, it's not just one task, it's many tasks. And so we really need that planning piece to break it into steps. And Deep Agents comes with a pre-built tool for that, along with task delegation to delegate to sub-agents as needed. The file system is huge for us, especially with this spec-driven development workflow. All the artifacts we're leveraging are files. We're creating a requirements document, we're creating a technical plan, architecture diagram. And so the file system was key to being able to write those files and edit them at different points. It's almost like a shared state. And it's also very helpful for configuring memory and using skills. And this is huge when it comes to context management as well, as I'm sure many of you are aware. The ability to load skills into the context at different periods when it's needed, rather than sticking everything into a large prompt. And in addition to that, Deep Agents provides middleware for conversation compaction to keep that context window in a good place. Of course, another piece to that is spawning sub-agents, which have context isolation. So each sub-agent will have its own context window that can be leveraged. And of course, sub-agents are also able to take on specialized tasks, which was big for us because requirements gathering and technical planning are two very different things. And then finally, a really key feature of Deep Agents is a complex system prompt. And a lot of people think that prompt engineering is dead. There's actually very detailed system prompts being used by, again, some of the most advanced, I think, agents that are running today, agents like Claude Code again. They have pages and pages of instructions to help guide their behavior. We found that Deep Agents provided us the perfect foundation for our goal to build a spec-driven development agent, with all of these features being really key to what we wanted to do. And so I'm going to hand it off to Ish, and he can kind of explain a little bit more about our implementation.
So, like Nate has said, despite how good these coding agents have become, we still aren't quite at the point where we can one-shot these really complex agentic systems. Now, me personally, I like to think of agentic engineering as an art. There's not one true solution. It's more about experimentation and rapid prototyping to eventually land on a finalized design. And that's exactly what we set out to build. The super agent is essentially our take on optimizing the SDLC or software development lifecycle. So now looking here at a high level, the super agent has a supervisor and 3 sub-agents. We've got the discovery agent, the planning agent, and the provisioning agent. These all agents use the pre-built deep agent framework. They have the full functionality of reading, writing, editing files, and they come in with all of those out of the box. On top of that, we've created a set of custom tools to help accelerate the development of these agents, and I'll go into a little more depth later on. But these tools include a specific ask user question. So like Nate mentioned, we both work for the platform team, and at United, we have internal documentation to our own platform that we need our agents to be aware of. And when they're surfacing questions as we're interacting with them, we want to make sure that they have the proper context. And so we've designed these tools in such a way. We also expose MCP servers, agents, and other tools throughout our platform. And we want the agent to have access to those. So we've designed a custom tool for that to happen. Finally, like he mentioned, we also have a file system backend, and we found through rigorous testing that this was one of the more optimal approaches for managing the agent's memory. And it's also how our artifacts are built. So now let's go a little more depth into this process for how the super agent works. Like I mentioned, we have a supervisor, and its main job is going to be to coordinate the 3 sub-agents and have them successfully execute their workflow. So let's start with the discovery agent. The discovery agent's main purpose is a requirements gathering specialist. So an individual will come with an idea, technical or not, and the discovery agent's job is to guide them through the whole process of development and translate it into a BRD. For those of you who don't know, it's a business requirement document. And this needs to be compliant with United standards. And how it works is, ironically enough, we're actually using the Focus framework to design this BRD, and it's an acronym. So F here is for functionality. What exact problem is the agent solving? Next, we look at O, the objectives. What are the business outcomes? What are the KPIs? What are the metrics? How do you determine success for your agentic solution? There are many things that we need to explore. C, for context. What info is needed? At United, we of course work with the airport domain. So is there specific domain context that needs to be injected into the agent as well? U is for users. We have both agents servicing different kinds of users. For example, you may have agents tailored toward internal employees. You may also have agents that are built externally facing customers. And each of these agents require specific setup and framework. S for sources. So one of the biggest challenges that we find with these complex agentic systems is that they're not given the right sources and documentation needed to solve the problem. And so we need to make sure that it has, if it needs to query from a database, that it has that appropriate tool and it has that appropriate connection as well. E for the environment. A lot of times we deal with sensitive data, and we need to make sure that the data is properly masked. We need to handle PII masking. We need to handle compliance and regulatory standards as well. And finally, D for dependencies. So agents can be built as part of an existing application. They can be built as a standalone agentic system. All these are technical decisions that an architect team needs to make when designing a system. And our goal is to optimize the development of this with our super agent trained and educated on our internal platform and capabilities that we offer. So moving on to the planning agent. Now we have a sophisticated business requirement document that's built. And the planning agent's main job is to now take these requirements and produce a validated technical architecture that aligns with our standards. And what we've noticed here is that many teams at United build with AI. In many cases, so many teams are building the same exact solution, not aware multiple teams are doing the same thing. And so what we've built into our planning agent is a large repository of our existing agentic projects. And we want to make sure that next time a similar problem surfaces, it's able to query this database and propose a similar solution. And so this one is grounded in the platform's capabilities. It has access to the MCP servers that other teams may have deployed. It has access to the agentic systems and it has access to many things. Now, this agent also does more than that. It makes technical decisions and assists the users on what technical decisions they need when designing their product. For example, what LLM should you pick? There are trade-offs, like Nate mentioned earlier. There's many trade-offs. Do you need RAG into your application? Are you going to do traditional or knowledge graph RAG? Do you have an embedding model? Is there a chunking strategy? Is there a re-ranker or vector database that you need? These are all decisions that need to be made. On top of this, it's also evaluating a subset of agentic patterns that we have created and exposed, and identifying which one makes sense and is most applicable for the use case. We also need to consider the guardrails that exist, and it uses our offerings to suggest the most relevant one, as well as create a specific task that lines with the user's intent. Finally, we have components that are not necessarily agentic. Take any service offered on AWS, S3, RDS, Postgres. A lot of our agentic systems need to incorporate a lot of this functionality. And so it's very important that the agent surfaces the best practices for building out these components and identifies that these components may be relevant to a specific use case. And so we've tested this out. It's performed really well, especially recently we tried it with a natural language to SQL use case, and it's done a great job of identifying various frameworks and architectures, but more importantly, it presents the trade-offs between each. So that way we still have the human in the loop aspect where they evaluate the architectures and they can personally say, hey, this may not be the best approach, or I can see why you chose a certain approach over the others. And dealing with integration, the explainability of these systems is especially important for adoption. Now moving on to the provisioning agent. This agent will we now have a BRD, we now have a technical document. And now this agent will actually take these approved documents by the user and provision the necessary architecture and infrastructure on our platform. For example, it's going to create apps on our AWS infrastructure and AI ML platform. It'll also provision the appropriate GitHubs from predefined templates as well. So we have templates for MCP servers, agent as a service, etc., backend, front end, etc. And so it will identify which components are needed and provision those appropriately. One really interesting thing that we found is as we're developing more and more agentic solutions, it's very useful to keep a repository of what I like to call working snippets. So these are just snippets of tried and tested code, whether it be something like connecting to a S3 or some arbitrary snippet that has been tried and tested. That way, when a new agent is trying to pick up or discover this functionality, it has a working example of how things work. And we found this to be very successful. Finally, it's also going to inject all the technical documentation into the GitHub repository, as well as provide the skills, the Claude MD or Agent MD in this case, into the files so that when users go and clone their repository, they have a fully set up environment for their coding agent to begin and working. So it's really that rounded down, it's really those three steps. And so we have here are some examples of some use case artifacts. I just want you to know these documents do get very long. So we have an example business requirement document. We have a technical plan and then an architecture diagram. And so these can range from hundreds to thousands of lines long, but they're very optimized for the specific use case, and they're tailored based on both the agent's feedback as well as the individual user themselves. One important thing to note is that agents rarely get it right the first time, and all of these documents are modifiable. For example, our architecture diagram is built using custom components to surface features that we have available on our platform. But we don't just inject the diagram into our GitHub. We provide the actual source code to generate it. This way, later on down the line, when inevitably there's going to be a change, we can account and adapt accordingly. So throughout this whole process, we've learned many things about agentic design, but three things stick out the most. The bottleneck was never code. Like Nate mentioned, teams are able to quickly iterate through prototypes, but agents sometimes have challenges understanding what the users latent intent meant when they were trying to communicate a problem. And this only comes with agents that are specifically trained on business domain knowledge. And many of you probably know this. If you use Claude Code for more than a day and had it run for more than 24 hours, you've seen that when you've taken that initial hour to go sit with Claude and plan out exactly how you want your design to be implemented, it performs a lot better than just one-shotting it. The next thing we learned is that human approval matters. Nowadays, we like to think that humans in the loop kind of is a bottleneck. It kind of slows us down. But in this use case, it's a feature, not a functionality. Agents get sidetracked really easily. They can get stuck on one arbitrary bug and loop for cycles on end trying to solve that. No one wants to discover that a wrong assumption has been made when real architecture has been provisioned. And so it's very important that humans are involved in this process through every single gate, like I've outlined earlier. Finally, we learned that file systems are great as working memory. These frontier models have been trained on tool call use, and they're really good at grab and glop, for example, navigating through really complex code bases. And these BRDs, plans, and artifacts are all injectable into our file system. The repository can scale, but the agent's context window is limited. So it's very important that we define easily navigable file systems and code bases, making the coding agent's job a lot easier. And this is especially important when you're starting new projects, because once you start with bad code, it takes hours to fix it, maybe even days. So overall, the future of software isn't a single prompt. I know many of you have maybe seen someone on Twitter or X claim to recreate Instagram in one day. The reality is that isn't the truth. That rarely happens. The reality is that coding agents have tremendously accelerated prototyping within the industry. You can quickly build POCs and iterate through them quickly. And so it's best that we take advantage of that. Spec-driven development provides a framework to do just this. We can quickly iterate and land on our ideal spec that we can take to production. And this is the true advantage. These agents, this agentic system can now design custom agents tailored to all kinds of use cases, regardless of what team is coming out, as long as it has that underlying business context, in our case, for United. And there's so many potential powerful combinations that it can make. It also finally enables non-technical teams to start designing agentic systems with an agentic frame lens. So with that, I just want to say thank you, everyone. And thank you to the Focused and LangChain team for hosting this amazing event. It has been an awesome opportunity to speak here. Thank you, guys.